All right, so number 37, it looks like a difficult problem, and by that means I don't recognize what to do. So it's nice to have these recipes over here. And again, they're written nicely. You may not remember this, it goes back to the beginning of the semester, but we have things like this, and it says use this over here. So let's just take it a shot. By the way, they give you a nice invertible region too to make things a lot easier for us. Let's write this down now. So taking their suggestion, x would equal a, which is 3, because 3 squared is 9, tan theta. And then I'll write down dx. And dx will be, let's see, 3 secant squared d theta. I'm going to take that suggestion, plug it in. So this one over here, which is what we want to do, let's put a little star here because I'm making a substitution. I need to go back to x's at some point. So it's going to be what? And it's going to be 9 tangent squared plus 9. And then you're going to get 3 secant squared theta d theta. Well, it looks awful. It looks worse than we have, but they say it's going to work out pretty nicely. And I'm kind of looking at this, and I realize the square root of 9, because I can factor it out, would be 3. And 3 times 3 is 9. And then I have the square root of tangent squared plus 1, which would be secant squared. In an invertible region, that's just secant. So you get secant cubed. And, I kind of remember just doing that problem, and I hope you do too. So I'll write this over as 9. And it's okay. Like if you're on an exam and you said, I just did that, why would I do it again? You're not going to do it again. You're going to look back in your problem sets, all right? So I think we just did that, but it's right over here. Look at that, right there. We just did it, fresh in my memory. So I want to write it down. And, so someone says, what are you writing down? I'm writing this thing down, all right? I'm writing it down. And, certainly a piece of paper, it's easier to figure it out, but let's write this down, all right? So I'll put this over here. I'm going to put down C star here. You know what? I'm going to need more room than that. I realize it's a really long thing to write down, all right? And again, there's nothing wrong with looking back over a problem set or things that you've already done, particularly on exam, by the way, because it was tough to get to that. I'll be honest with you. We got there. But this is going to be natural log. And again, you can look back over. We just finished that. Now, it's not going to be secant of x. It's going to be secant of theta now. Let's keep moving. Plus the tangent of theta. This is the absolute value. Plus secant theta. And tangent theta. Well, that's not so bad. I'm going to get my eraser out now. I'm a little too far with that fraction bar. Over 2. And this is going to be plus some constant of integration. So that's going to be C star. Okay, you might think you're done. You're not done. All right? Now, what's nice about these recipes, they pick a really nice invertible region. So let's write down what tan theta is. Tan theta, again, I'm looking at the substitution we made, is going to be x over 3. But I also need to know the secant of theta. And the way we did this way back when was we drew a triangle. This is theta. Tangent of theta is x over 3, so this is x, this is 3. And this will be the square root of x squared plus 9. So the secant is going to be the square root of x squared plus 9 over 3. All right? So I think I can do that now. And let's write this down. It's 9 halves. We'll check the key later. And that's going to be the natural log of the secant of theta. And I just think I just did that. Yeah, square root x squared plus 9 over 3 plus the tan of theta, that's x over 3. Let's keep moving. plus the secant of theta, that's the square root of x squared plus 9 over 3 times the tangent. Oops, I'm sorry. I know the tangent. What am I writing that down? I want to get in terms of x's, right? And what do you get there? That's just x over 3, right? And I'm going to put down C1 now. All right? So I'm not done yet. And I want to write this down a little more carefully. I can write it as, let's see, 9 halves. And this is going to be the natural log of the x squared plus 9 plus x minus, I hope you know there's a fraction there. I'm just doing the rules of logs over here. It's going to be the log of 3. So ln 3. There's no need for absolute value there. This is going to be plus, and you're going to get the x times the square root of x squared plus 9 over 9 plus C1. And I'm going to try to simplify it. And you're going to get, let's see, 9, the natural log, absolute value, x squared plus 9. Whoops, I just made a mistake there. I'm daydreaming. It's the square root, sorry about that. X squared plus 9 plus x, close that out. That's over 2. 9 half times that number there is going to be, I'll put it on the other side, it's going to be 9 halves ln 3 plus C1. I'm going to say minus that. All right, so we took care of a couple terms. Let me put the next one down. The next one's going to be plus x, the square root of x squared plus 9. Well, let's see. The 9 is going to cancel, get a 2. And things are starting to shape up pretty nicely, by the way. So I'm going to say this is equal to, there's going to be a 2, there's going to be a 9 there, ln, absolute value, the square root, x squared plus 9, plus x, absolute value, and then you get plus x, the square root, x squared plus 9. They're both over 2, by the way. And this I'm going to call a new constant. I was going to call it C2. I'm going to commit to this answer. It's probably the neatest answer I could get. And I'm going to look at the answer key now, see how we did. All right, we're going to see if we have what we need. I see the 2. I see 9. The natural log of the root of x. Yeah, looks great. And I see this. And I see the constant. And we're good to go on. Thank you.